Hello everyone, welcome to today's class of Pharmaceutical Organic Chemistry. I am Rosalind Mishra, Assistant Professor, ITS College of Pharmacy. I welcome all of you students to our today's class dealing with carboxylic acids and its derivatives and aliphatic amines. Now, this is the second part, as you all can see. Today's topic consists of structures and uses of named carboxylic compounds and their derivatives. In our previous class, we had discussed about structures and uses of few carboxylic acid derivatives. In today's class, we shall continue the same. Okay, so now our today's first compound which we are going to discuss would be succinic acid. Okay, so we shall understand the structure of succinic acid, few physical parameters, few chemical properties, and most importantly the uses of succinic acid. Now, succinic acid is a dicarboxylic acid, okay, that is it contains 2 COOH group. It is a dicarboxylic acid having a chemical formula CH2 twice, COOH twice. As I told you all, it is a dicarboxylic acid having 2 carboxylic groups, 2 carboxyl groups. The name derives from a Latin word succinum, which means amber. Succinates can exit the mitochondrial matrix and function in the cytoplasm as well as the extracellular space, changing gene expression patterns. As a diprotic acid, succinic acid undergoes 2 successive deprotonation reactions. The pKa of these processes are 4.3 and 5.6. I shall repeat again. As a diprotic acid, since it contains 2 carboxylic acid, it is considered to be a diprotic acid. Okay. So, as a diprotic acid, succinic acid undergoes 2 successive deprotonation reaction, that is removal of hydrogen bond. The pKa of these processes are 4.3 and 5.6. The IUPAC name of succinic acid is butanedioic acid. It is also known as 1,4-butanedioic acid. It has got a chemical formula of C4H6O4. It has a molar mass of 118.09 gram per mole. It is a crystalline white solid, has a melting point of 184 degrees Celsius. It is soluble in water, alcohol and glycerol. Now, this is the structure of succinic acid. As we had already discussed, succinic acid is a dicarboxylic acid. It is a dicarboxylic acid. Now, moving on to the uses of succinic acid. Succinic acid regulates cardiomyocytes. It acts as a cardiomyocyte regulator. It means that it helps the heart pump the blood properly. It helps the heart in pumping the blood in a proper manner. This is good for people suffering from cardiovascular disorder. Okay. So, succinic acid is considered to be good for people dealing with cardiovascular disorders. Succinic acid is even been known to help prevent heart attacks. So, basically they act as cardiomyocyte supporters, or they regulate the cardiac myocytes, hence they help in people suffering from heart diseases or cardiac disorders. They also help in preventing heart attacks. Next, succinic acid is used as an acidity regulator and as a pH regulator in food industry. Okay. So, apart from its medicinal use, succinic acid is also used as a pH regulator and an acidity regulator in food industry. Succinic acid can be used as a masking or buffering agent in cosmetics and personal care products. Succinic acid has got its use as a masking, buffering agent in cosmetics and personal care products. The analgesic properties of succinic acid makes it a great remedy for ailments. Reducing irritability and preventing menopause are one of the few roles which are played by succinic acid. Succinic acid has also played a key role in healing and providing pain relief. Okay. So, succinic acid, apart from being used as an acidity regulator, as a pH regulator, has got a range of medicinal use as well, starting from preventing heart attacks to regulating cardiomyocytes. They are also used as analgesics. Okay, that is, they have their role in relieving pain. Okay. They are also known to reduce irritability. They are also known to prevent menopause. Succinic acid has also played various key roles in healing and preventing pain relief or providing pain relief. Now, so after succinic acid, we shall move on to our next carboxylic acid derivative, which is oxalic acid. Okay. Oxalic acid is an organic compound with the chemical formula C2H2O4. Oxalic acid has got a chemical formula of C2H2O4. It is a colorless crystalline solid that forms a colorless solution in water. It is a colorless crystalline solid that forms a colorless solution in water. Its condensed formula is HCOOH. Okay. So, basically it has got a chemical structure of COOH, reflecting its classification as the simplest dicarboxylic acid. Okay. So, oxalic acid, like succinic acid, is a dicarboxylic acid. It is the simplest, most carboxylic acid. Its acid strength is much greater than that of acetic acid. Being a diprotic acid or being a dicarboxylic acid, the acidic strength of oxalic acid is much greater than that of acetic acid. Oxalic acid is a reducing agent and its conjugate base is known as oxalate. Oxalic acid conjugate base are known as oxalates, which can be denoted by C2O2 4 times. It is a chelating agent. Oxalic acid is known to act as a chelating agent for metal cations. They act as chelating agent for metal cations. Typically, oxalic acid occurs as dihydrate with a formula C2H2O4.2H2O. So, in nature or typically or usually, oxalic acid occurs in the form of dihydrate, which can also be written as C2H2O4.2H2O. So, these are the few characteristics of oxalic acid. Now, let us look into the structure of oxalic acid and its physical and chemical properties in brief. So, this is the structure of oxalic acid, As I told you all, it is a dicarboxylic acid. So, having two COOH groups. It is a diprotic acid. It has got an IUPAC name, or it is known as ethane dioic acid. Other names of oxalic acid include wood bleach. The chemical formula of oxalic acid is C2H2O4. It has a molar mass of 90.03 gram per mole. It is white crystalline solid. It is crystalline in nature, has a melting point of 189 to 190 degrees Celsius. When we talk about the solubility, it is soluble in water, it is soluble in alcohol, glycerol and diethyl ethers. Okay. So, now oxalic acid has an IUPAC name, also known as ethane dioic acid. The other common names of oxalic acid, or commonly oxalic acid, is known as wood bleach. It has a chemical formula of C2H2O4, a molar mass of 90.03 gram per mole. It appears as white crystals having a melting point of 189 to 191 degrees Celsius. It is soluble in water, alcohol, glycerol, diethyl ethers. Now, talking about the uses, it is used as a cleaning agent. Okay. Oxalic acids are used as cleaning agents. The oxalic acid is an ideal chemical for cleaning purposes. Its bleach like quality makes it perfect for sterilizing household items. Okay. Now, when we talk about its industrial use, this acid is sometimes used in mineral processing mechanisms. Its bleaching properties can be used to sterilize equipments in a number of corporate environments. Okay. The textile mills and factories use it for bleaching in order to color clothes. So, basically, apart from being used as a cleaning agent, oxalic acid also finds its use as in industrial purposes also. In the industry, it is used for mineral processing, it is used for its bleaching ability, it is used in textile mills and factories for bleaching purpose. Other uses include, aside from its bleaching ability, they also have rust removing capacity, they have stain removing capacity. Oxalic acid is also used as a reducing agent in developing photographic films. It is also used in waste water treatments as well. Since oxalic acid can effectively remove calcium from waste water. So, we can see very well that oxalic acid has got a lot of potential in industrial uses. Lastly, oxalic acid is also used as grinding agent for polishing marbles. Now, apart from these industrial uses, oxalic acid also has various use in as a medicinal agent. Okay. So, now we will discuss about the medicinal properties of oxalic acids. Oxalic acid does not present any problem medicinally. In its raw form, it is one of the most important minerals needed in the body to maintain tone and peristalsis of the bowel. So, it is helpful in maintaining the bowel movement. Talking about its negative effect, the negative effect of oxalic acid is that it may contribute towards kidney stones. Oxalic acid may lead to kidney stones. Normally, calcium and small amount of oxalates are present in the urinary tract. At the same time, but they remain in dissolved form and does not cause any problem. Okay. These oxalate crystals, they are usually present in dissolved forms, but apparently there are times when they bind to form crystals. Then they create a problem. When they convert into crystalline form, they get deposited in the form of kidney stones. These crystals can lead to the formation of stones, especially when oxalate content is high and urine volume is low. Okay. So, now moving on to the next compound, which is benzoic acid. Now, benzoic acid is a colorless crystalline solid and a simple aromatic carboxylic acid. Very simple, C6H5COOH comprises the benzoic acid. Okay. It is an aromatic carboxylic acid. The name is derived from benzoin gum. The IUPAC name of benzoic acid is benzene carboxylic acid. Okay. It is also known as carboxybenzene. They are also known as tricyclic acid. They are also known as phenyl methanoic acid. Okay. It has got a chemical formula of C7H6O2. The molar mass of benzoic acid is 122.12 gram per mole. It has got a molar mass of 122.12 gram per mole. It is colorless crystalline solid, has a melting point of 122 degrees Celsius. When we talk about the solubility of benzoin, it is soluble in water, alcohol, glycerol, diethyl ether, etc. Now, moving on towards uses of benzoin. First, let us focus upon its medicinal use. Okay. So, benzoic acid is used for treatment of fungal skin infections such as tinea worm infection, ringworm infection, and a condition called as athlete's foot. Benzoic acid is also used as an expectorant in cough preparations. They are used as analgesics. They are also used as antiseptics. The antiseptic use of benzoic acid is since 20th century. Now, apart from all these medicinal uses, benzoic acid also is used as a preservative. Benzoic acid and its salts are used as food preservatives. Now, let us move on to the next carboxylic acid derivative, which is salicylic acid. Okay. Salicylic acid is a compound obtained from the bark of the white willow tree, Salix alba. Okay. So, salicylic acid was first obtained from Salix alba, also known as white willow tree. Salicylic acid is lipophilic in nature. It is a monohydroxy benzoic acid, a type of phenolic acid also known as beta hydroxy acid. Beta hydroxy acid. Okay. It contains a carboxylic acid group and a phenolic ring or hydroxy group at beta position, giving it the name of beta hydroxy acid. Next, the IUPAC name of salicylic acid is 2-hydroxy benzoic acid. Okay. So, salicylic acid is also known as 2-hydroxy benzoic acid. It has a chemical formula of C7H6O3, a molar mass of 138.12 gram per mole. They are colorless to white crystalline solids. It has a melting point of 158.6 degrees Celsius. When talking about their solubility, salicylic acid is slightly soluble in water. They are soluble in ether, benzene and ethanol. Moving on to the uses of salicylic acid. Well, Let us first discuss about the medicinal uses of salicylic acid. Salicylic acid is used for the treatment of acne. It is a skin condition characterized by red pimples on the skin, especially on the face, due to inflamed or infected sebaceous glands. Okay. So, salicylic acid is one of the major components which are used for the treatment of acne, a skin condition which generally affects the adolescents. Okay. What happens is red pimply skin is mainly seen, especially on the face. It is due to inflamed sebaceous glands. Salicylic acid is also used in psoriasis. It is a skin disease marked by red, itchy, scaly patches on the skin. Next, it is also used in seborrheic dermatitis. Again, it is a skin condition wherein mainly affecting the scalp. Okay. It causes scaly patches, red skin and stubborn dandruff. It can also affect oily areas of the body. Apart from the scalp, this seborrheic dermatitis can also be caused in oily areas of the body, such as face, sides of the nose, eyebrows, ears, eyelids, etc. Now, apart from being used in acne treatment, apart from being used in psoriasis treatment and a type of dermatitis, salicylic acid finds its application in treatment of eczema. Eczema is an inflammatory condition. It is an inflammatory condition of the skin which is characterized by redness, itching, oozing vesicular lesions which become scaly, crusted or hardened. Now, viral warts are again another type of, it's a skin condition in which salicylic acid plays a treatment role. It is typically small, rough and hard growths that are similar in color to the rest of the skin. Next, dandruff. Salicylic acid helps in treating dandruff. They help in treating ringworm infection. What is this ringworm infection? It is a contagious itching skin disease occurring in small circular patches caused by any of fungal family, affecting chiefly the scalp of the feet or the feet. The commonest form is athlete's foot. Now, if we talk about the chemistry of salicylic acid, it is used for synthesis of, or if we talk about the chemical use of salicylic acid, it is used for synthesizing aspirin. Okay. The most common anti-analgesic drug, aspirin, or anti-inflammatory drug, non-steroidal anti-inflammatory drug, aspirin, which is acetyl salicylic acid. So, it is the starting material for synthesis of aspirin. Other uses of salicylic acid include, it is used as a food preservative, it is used as a bactericidal and an antiseptic. So, now moving on to our next compound, which is acetyl salicylic acid. Also known as aspirin, it is a non-steroidal anti-inflammatory drug. Aspirin is also known as acetyl salicylic acid. It is a medication used to treat pain, fever or inflammation. The IUPAC name of aspirin is 2-acetoxy-benzoic acid. It is also known as acetyl salicylic acid or aspirin. It has a chemical formula of C9H8O4, a molar mass of 180.15 gram per mole. It is a colorless white crystal having a melting point of 136 degrees Celsius. It is soluble in water. Uses of aspirin include, it is used in the treatment of a number of conditions including fever, pain, rheumatic fever and inflammatory diseases. It is sometimes used to treat or prevent heart attacks, strokes and chest pain. Aspirin is thought to reduce the overall risk of getting cancer as well. Next structure, methyl salicylate. It is a methyl ester of salicylic acid produced by many species of plant, particularly wintergreens. It is also synthetically produced. It is used in high concentration as a rubefacient and analgesic in deep heating liniments. It is used in low concentrations as a flavoring agent also. Methyl salicylate is a non-selective COX inhibitor. It is used as an anti-inflammatory agent and an analgesic agent. The next compound is benzoyl benzoate. It is a medication and an insect repellent. It was first studied medically in 1918. These are the few characteristics of benzoyl benzoate. Talking about their medicinal uses, 25% of benzyl benzoate is used for treating scabies and pediculosis. It is also used as an excipient in testosterone replacement therapy. It has got a lot of non-medicinal use as well. The last compound is dimethyl phthalate. It is used as insect repellent. It is also used as an ectoparasiticide and has many other uses, including in rocket propellants as well. So, these are the references. We shall end today's class with this note. We shall continue aliphatic amines in the next class. Thank you all of you.